We ready? Okay. Yeah. So, properties of parallelograms. The opposite sides are parallel. Interesting, isn't it? That's why they're called parallelograms. Opposite sides are parallel. And to mark that in a picture, you draw these little arrows. You say this is parallel to this. That's how they write it. And then this side is parallel to this side. So if you see a drawing and those are the markings, that's what they're trying to tell you, is that they're parallel.
What if the arrows are right? Wait.
It doesn't matter.
Never mind what I said.
Yeah, it doesn't matter which way they go. All right. We're going to go ahead and label each of these vertices. So I'm going to call this parallelogram A, B, C,
And Z.
D for Daryl.
I need them.
And so AB is parallel to CD. BC is parallel to AD. Okay? These sides are also equal in length, and the word that we use for that is congruent. If they are the same length, they are congruent. And to mark that, we do one little tick mark. So, and then two tick marks. Okay, so we have AB is congruent to CD, and BC is congruent to AD. Opposite angles are also congruent. And what I mean by opposite angles is the ones that are like across from each other. So angle D and angle B are the same. Angle A and angle C are the same. Let me draw that better. So angle A is congruent to angle C. Angle B is congruent to angle D. So if you need to write a note to yourself, when they use the word opposite, they mean across from. So angles that are across from each other, sides that are across from each other. When they say consecutive, they mean in a row. So two angles in a row would be like angle B and angle C, or angle D and angle C, or A and D. Consecutive angles are supplementary. What does supplementary mean? They add to 180. Complementary would be 90. Yep, so supplementary is 180, complementary is 90. So we're going to say the measure of angle A plus the measure of angle B is going to equal 180 degrees. I am not going to write down all the different ways that that can happen in this triangle, or in this parallelogram. But you get the idea. And then diagonals bisect each other. Anyone remember what bisect means? They cut each other in half. So I'm going to draw the diagonals with a dotted line. So here's one diagonal. Anyone want to guess why it's called a diagonal? Because it goes diagonal. Tricky, tricky, huh? Such a hard question. It's like those people who name their dog Dog.
I call my dog Dog.
All right, so since it's bisected, this half of the diagonal equals this half of the diagonal. And this half of the diagonal equals that half of the diagonal.
It's like art.
Mm-hmm. Yeah, isn't it? So let's go ahead and call this right in here. We're going to call this E. And so we're going to say DE is congruent to EB, and AE is congruent to EC, so they're the same length. Okay. Oh, that was so fun. Let's do some more. A rectangle is a specific type of parallelogram, and it has all the same properties of a parallelogram. So a rectangle still has opposite sides that are parallel and opposite sides that are equal in length. It still has opposite angles that are congruent. The consecutive angles are still supplementary. The diagonals still bisect each other. That's still true for a rectangle. And also, we have some extra properties that every angle is 90 degrees. And the diagonals are congruent. So the two diagonals are actually the same length. Not only do they bisect each other, but they're actually the same length. A square is a specific type of parallelogram and a specific type of rectangle. So it has all the same properties of parallelograms and rectangles. So squares have opposite sides that are parallel and equal. Its opposite angles are congruent. Its consecutive angles are supplementary. Its diagonals bisect each other. Its angles, all of the angles are 90. All the diagonals are congruent. And we have some extra stuff. All sides are equal in length, all four of them. The diagonals bisect the opposite angles, so the diagonals cut the opposite angles in half, and the diagonals are perpendicular to each other. All right, a rhombus. Anyone remember what a rhombus looks like?
It looks like a square, but it's tilted.
Yeah, it's like a square somebody pushed really hard. A rhombus is a specific type of parallelogram, and it has all the same properties of a parallelogram. So its opposite sides are parallel, its opposite sides are equal, the opposite angles are congruent, the consecutive angles are supplementary, the diagonals bisect each other. It has all that. And all the sides are equal in length. The diagonals bisect opposite angles, and diagonals are perpendicular to each other. What does that sound familiar to?
Square.
Sounds like a square. So a square is an example of a rhombus.
What's a rhombus look like again?
A square you pushed over. It's like this, but square. More square and less rectangular. It'd be like that.
Oh, gotcha.
Yeah. All right, so a square is a specific example of a rhombus. Okay, so we're going to write that down here. A square is a specific example of a rhombus. Yeah.
What would you call the 3D prism around this?
A beat up cube.
Wow.
Actually, maybe an oblique cube?
Okay. Okay.
I don't know.
Beat up one better.
Yeah, beat up cube.
Should punch the
Cube got punched in the face.
Well,
All right.
attempt on that.
Now, the specifications for the EOC said that I have to cover parallelograms. They suggested doing this if we have time, which we don't. So today we know these things, right? And I think that most of this stuff is somewhat familiar. Am I right about that? So you have it on your sheet if you need to refer to it, but today is going to focus on just the stuff at the top. Does that make sense? Okay. So I have an assignment for you, and if you cover up all of it and just use the top part of your notes, that's what the assignment's going to use. Sound good? Okay. I think what we're going to do for the test coming up on
Magic.
Oh, I don't know.
Tuesday, this is the last day of learning, so we review Monday, we test Tuesday, okay? So I think what I'm going to do for the test is say that we can just use our cheat sheet for the entire test because there's been so many things. Reasonable? Yeah? Okay. You have to remind me of that. I'm videotaping it, so you have, like, my word on YouTube for the rest of all days. Okay? So work on your cheat sheets, make them great, use them the entire test on Tuesday. Sound good? Mr. Rice, can my quiz review be my, or can my test review be my cheat sheet? No. Okay?
Dang it.
Okay, what page of the test?
I already
will
made
you
a
get?
fantastic.
Ms. Rice, can one page of the test review be my cheat sheet? No,
Ah,
because I just said so, and I
but
recorded
it's
it, so
one
it's real.
sheet, though.
It's one piece of
Sorry,
paper.
I already said no.
It's not real.
If I don't record it, it's not real, but now we got witnesses, all of YouTube, because all of YouTube will watch this video. I am very adamant that we are not doing rectangles today.
Okay.
Okay.
I'll cover it.
So,
Rectangles.
the plan from here on out is to finish your parallelogram assignment, which is 2 pages, front and back. And while you were doing that, I'm going to update your grades and print you a progress report. Sound good?
Yes.
Yes, Ms. Rice? Okay.
Wait, we have homework for the weekend? Of course we do.